Working on this problem, we found one thing after another fell into place, and more wonders were unraveled each day. First of all, we quickly saw that the story extended to all dimensions, all the way up to the SL2Z and 2B in the 10 dimensions, and that the BPS spectrum was key. We found that duality-related string states to p-branes, and that provided strong evidence that the supergravity p-brane solutions in fact corresponded to precise quantum states of the full quantum theory. And we found that because the dualities related the branes to the fundamental string states, there was all were on the same footing. There was what Paul later called a p-brane democracy. And the string theory could no longer be a theory of strings, but the branes were there on the same footing. They were a fundamental part of that. So non-determinatively, the theory was no longer a theory of just strings. We found that the mysterious Ramond-Ramond gauge fields played a group theory that the Ramond-Ramond gauge fields playing a crucial role, and they coupled precisely to, and despite the fact that there were no fundamental string states they coupled to, we found that their role was in coupling to certain brane states, which we now call D-branes. And then we realized that we could take the whole story of analyzing the BPS spectrum and what that told us about the theory much further. We looked at the 2A and 2B theory, or 2A or 2B theory on K3 cross T2, and saw that non-determinatively this could be dual to either of the heterotic strings on T6, amazingly unifying 4 of the 5 string theories in one theory. We realized that still left the open string theory, and we thought there would be time to come back to that. That still seemed mysterious at the time. But extraordinarily, this meant that type 2 theory was back. It was dual to the heterotic string, and that meant that it was necessarily we could get non-abelian gauge symmetry and chiral fermions from type 2, just as you could from heterotic. Although it wasn't until later in Ed Witten's work that was understood how that worked, what the mechanism for that was. But we also were struck by the fact that there was an 11-dimensional version as part of the story, that the whole BPS spectrum could lift up to 11 dimensions, and that the fundamental string lifted up, and it's long known that that fundamental string lifted up to a membrane wrapping on a circle. And so there was a tantalizing prospect of lifting string theory up to 11 dimensions. So we had lots and lots of discussions about that and what it meant. And in the end of the paper, we made some brief and rather cautious comments. One of the key problems was that we had no idea how the quantum theory could possibly work in 11 dimensions. Now we have, of course, much stronger evidence that 11 dimensions is necessarily part of the story. But there's still remarkably been very little progress in understanding what's really going on at the fundamental level in 11 dimensions. So after this work, we were very excited with our results, and we understood the potential importance of what we found, and we were rather disappointed that there was relatively cautious reaction. There was, we got just one citation between the paper coming out and Strings95, and that was a reference for our discussion, for our mentioning of the E10. There was one notable exception, as is often in these stories, and that was Ed Witten took a very early interest. I visited Paris in the summer when we were working on the work, and for once, when he asked his usual question, "What are you working on?" I had a good answer, and his interest and encouragement was very important in the development of our work. And perhaps the transition between the attention our paper got from when it was published until Strings95, and then the huge amount of interest and attention we got after Strings95 is probably a very good example of Paul Ginspard's 4 stages of physics failure. So I want to I want to now come about what are the lessons of this. What could we learn from this for the future? When is the next string revolution? And so one thing one could do is look back in the past, look back to Strings93 and try and ask whether there are any signs of what was to come in Strings93. And for example, if there was a vision session in Strings93, what would they have said about the future? And interesting enough, looking back at the proceedings of Strings93, this is the time when proceedings was written up in book form. There are a lot of familiar subjects. There's a lot of familiarity in what was talked about. There was a lot of work on two-dimensional dilaton gravity, a lot of talks on black holes, especially in 2 dimensions, a lot of work on formal field theory, and a little bit on higher spin, especially in the guise of W gravity and W strings, and very little actual string, fundamental string theory. And so a vision session in Strings93 could probably have a pretty good vision of at least some of the things which we talked about 25 years later. But nonetheless, looking a bit harder, there were also some very interesting duality talks in talks in the proceedings. In particular, John Schwartz had a paper, a prescient paper, talk entitled "Does String Theory Have a Duality Symmetry Relating Weak and Strong Coupling?" And this was based on his work with Ashok Sen, and this is a question which was then addressed by Ashok in the following year. So I think at this point it would be, since it's a pre-dinner after-dinner speech, and a lot of you are hungry and sober and ready to go on with the proceedings, it's probably a good time to wind things up. And thank you for the opportunity to reminisce about my 15 minutes of physics fame, and to raise a toast to 2 things. Well, first of all, to the next strings revolution, whenever it may be, and maybe there is evidence within the talks we've heard this week about where that will come from. And more importantly, to thank the organisers for organising an amazing and stimulating and very enjoyable conference. So thank you.